Alright everyone, welcome to Advent of Code Day 12. We're here. Microphone, I'm looking over there, it's working. Sorry about yesterday not having a microphone, but back anyways. Today, here's hoping that we don't have any missteps or anything. Let's just get through it. Here's hoping. Day 12, let us do it. You try connecting the L's using your handheld device, but the river you're following must be too low to get a decent signal. You ask the device for a height map of the surrounding area, puzzle input. Your height map shows the local area from above, broken into a grid. The elevation of each square is a grid. The grid is given by a single lowercase letter, where A is the lowest elevation, B is next, and so on to Z. Also included in the height map are marks for your current position. S as the location you should get the base signal, or the best signal. Our current position, E, or current position S has an elevation A. The location where you should get best signal has an elevation Z. You'd like to reach E, but to save energy, you should do it as few steps as possible. During each step, you can move exactly one square up, down, left, or right. To avoid needing to get out of your climbing gear, the elevation of the destination square is the most one higher. At most one higher than your, okay. If your current elevation is M, this is sounding like technically it's supposed to be like an A star. I only know flood fill. Yeah. That was cool. So yeah, so I only know flood fill. So that's what we're gonna be doing. So given this, we need to take this in and parse it, and we're gonna let's just parse into a grid here. So we'll do public map position or point and integer grid. If you know A star, this is probably easier to do, but I don't know A star off the top of my head. So for string S and inputs, JK int row equals 0, row is less than input dot size, row plus plus, input dot get row, int column 0, a column is less than s dot length, column plus plus. And then we're going to do grid, put new point, row, column, and then put in s dot chart at column minus A. Char C. Actually, I need to do this because of the S and E. If C equals S, C equals A, or if C equals E, is going to be Z. Now we can do C. Okay, so given that, now we have our grid. So now we got to do flood fill. So, trying to think. I feel like flood fill is not. It's not flood. It's a priority flood fill is what it is. It is what I want. It's the flood fill, but there's a property I'm missing. That's how you get the lowest path to it. It's right, lowest path. Yeah, fewest possible. I want a priority queue, but what's my priority? Well, first let's just figure out this first. I do need to hold a point. This is start. And an end. Please also change to where we do starts equals P. And then here end equals P. So we need a list of points. This is our queue that will have to have some sort of priority to it. I don't know off the top of my head right now what that's going to be. And then while, is that right? We could do a flood. We could do this the more brute forcey way, which is do a flood and then keep track of the path and then always override the point with the quickest path to that point. I think we're gonna do that because I can't think of a better priority queue way. So what we're gonna do is we're gonna have to do a map of a point with an integer, and this is going to be shortest path. That way you don't have to worry about this being a queue. Hash map, okay. And so we do shortest path dot put start 0, and then we need to do queue add start. So our queue dot size is greater than 0. Go ahead and do this logic. First thing we do is we do point p is going to be equal to queue remove 0. And then what we need to do is we need to go ahead and add the squares around this one. Actually, we do need to do int path length shortest path get p. So point up is going to be equal to new point, and that's going to be p dot row plus 1 p dot. Technically it's actually not up, but it will. No, we'll do it the right way, where it's upper left is 0 0. So -1 and then dot column. So we're gonna have up, down, left, right, down, left, right, left and right. So now what we have to do is we have to do a check here. If we also need the int height is going to be equal to grid get p. So if height, if math dot absolute of height minus grid get up is less than or equal to 1, that means up is valid. So what we need to do now is get the shortest path. Shortest path dot get or default for up, with the default being integer dot max value. And then we do a check here if up path is less than or is greater than path length plus 1. That means that we have found a shorter path. And we don't want to add it to queue. Yes, we only want to add it if we found a shorter path to it. Because we found a shorter path to it, that means we need to do is queue dot add up, and then also update shortest path dot put, it's just fine, up, and then path length plus 1. I think that's it. I don't think there's anything else we need to do for this. So now we just got to go through all of these. So instead of up, it's now down. I should make this like a method or something. Void do logic. I don't know. So this needs. It's gonna need point P. I guess we'll have to do this here. Point P, point direction. So down becomes dir. Path length we can calculate again. It's not the fastest, but sure. So this needs to take in also shortest path. And then also needs to take in the queue. Okay, so now we can just go ahead and just do this manually on do logic. P up, shortest path, and queue. Do the logic for each of these. Technically I could just a new point, but whatever. Okay. And then once that finishes, all we have to do is just do lap, and we just do shortest path get end, I think. It's not end. Oh, okay, well, you know, technically it should never happen, but let me just do return, and we can do a system.out.println. You done messed up. All right, what do we get? This grid is null because I made it out here for whatever reason. Okay. Cannot invoke is null. I need maxes. Public static int width and height. It's gonna keep it as a bunch, but this is fine. No, fine. I'll do it this the more right way. So width is going to be equal to input dot get 0, and height is going to be equal to input dot size. So I need these because we need to make sure that we're not going to go out of bounds. So I guess we should put this here, because now I need to do is if p dot row equals or does not equal 0. That's fine. And these all need it. So now this is now p dot row is not equal to height minus 1. And technically I don't need to move these, but I am. And this is going to be column now. And this is going to be width. Yeah, technically I did not need to move these because the point didn't care. It was that logic that cared. But either way. Ah, it doesn't like it though. Huh. I thought that was wrong. But apparently not. Oh, well, I didn't change that to column, so maybe it was still wrong. Nope. Oh. It doesn't find end now. It's been like, I don't even know how many minutes. It's been a while, and I finally figured out my issue is not because of this logic. This logic is actually all correct. Everything's right. It's because this is wrong. Yeah. You can go down as many as you want, but you can't go up. The up is the thing. So if the point we're going to is less than or equal to 1, this should at least get me there. This should give me an answer of 212. This is backwards. Is that backwards? Yeah, it's backwards. 520. Please tell me that's the answer. I hate reading. Part 2, as you walk up the hill, you suspect that the elves will want you to turn this into a hiking trail. The beginning isn't very scientific, though perhaps you can find a better starting point. Maximize exercise while hiking. The trail should start as low as possible, elevation A. The goal is to still get to mark E. However, the trail should be as direct, taking as few steps to reach its goal. So you define the shortest path from any square to at an elevation A. 5 marked A plus the square marked S. That counts as being the elevation we start at. Path reaches the goal. So then we have to find the A that has the shortest path. What that means is this. Right? Because if I wanted to just make the shortest path, I just ignore A. So that's just if int no. I could move this. It should be int grid height. Or no, this one. Sure. If the grid, so if grid height is equal to 0, just leave 0, otherwise there. Right? This will give me a different part 1, but I think there we go. Okay, well, that would have been a lot. I would have done it a lot faster had I read the question correctly and correctly comprehended it. Is there any way I can do this for part 1 versus part 2? Can I I don't want to. Okay. Public void do part. we will pass in the start and end. And so what I just need to do is I need to do Boolean part 1. So some testing data here. Do part start end true, start end false. Okay. And then this gets passed in to do logic. Which then takes it, and we do that. And in theory, we should get part 1, part 2 that are backwards somehow. That's why. And there we go, part 1, part 2. Why'd I have to read that wrong? It's so annoying. All right, anyways, explanation. So today's problem is basically comes down to a flood fill. We want to get from, on this map, we want to get from S here to E here. And each character in between is an elevation. Lowercase a being the lowest, Z being the highest. S starts at lowercase a, E ends on a lowercase z. And we want to get from from A to Z in as few as many steps as possible. But we can only go up a maximum of 1 elevation unit. You can go down as many as you want. That's what I messed up. But you can only go up 1 elevation unit. So the first step is to just go through and parse our inputs. This is simple. We just go row by row, column by column, row by row of the inputs, or line by line of the inputs, character by character of the outputs, or of the input line. To get a row and column, we create a point for that. We check for the uppercase S and uppercase E. We save those as point and end respectively if needed, and also change that character to be an A and Z just for the grid to work fine. And then we go ahead and add it to the grid. I subtract off lowercase a because again these are characters or these are chars, so they are numbers. And I just subtract off a just that way we start at 0 and go up to 25. And then we go ahead and we actually do the logic. So you can see part 1 and part 2 are the same logic. However, there's one little trap that the part 1 here will carry. But anyways, we do what is called a flood fill. You start at a point, you check all of the surrounding points, in this case, the 4 surrounding cells of that point. As you can see here, we check the up, down, left, and right points. And then in that check, what we do is we get the height of the grid at the point to check. We see if the height of the grid spot we're at is at most 1 greater than it or anything lower than that. And if it is, we go ahead and we calculate the path from the current cell to this. This is done by we have a shortest path map that we keep track of. This always has the smallest path to the cell. It starts off as a max integer value for a cell, and then as we visit it, it'll check that the path length of the current cell we're at plus 1 is less than the currently stored shortest path for that cell. Because it started max integer, whenever we visit the first time, we always have a lower number. This path starts at 0, so when we initialize this with the starting cell. We initialize it at 0 because it's 0 moves to the cell. Whoops. And because the queue here, this queue is storing all of the locations to look at, we also start this at 0. So because of that, this will always have either 0 or max number. And then as we visit cells, it'll slowly change those from max value to be whatever the now shortest path is. That way, if we kind of branch out a lot and then we finally get to a cell we've already visited, we only want to add that cell back to the queue to check again in the future if that is a shorter path to that cell. If it's a longer path, we don't care because while this path is dead, you only want the shortest path. And then here's where we come in for the part 1 versus part 2. If this is part 1, we just simply add in length plus 1 to the current path plus 1. That way it's incrementing by it. But if this is part 2, we check the grid height. If the grid height is 0, that means we are at lowercase a. We just save back 0 to the shortest path, because again, any of the a's could be our starting point, so they will always be 0. So that's how that works. And then this loop here just keeps running forever until we have a queue that's empty. This queue empty meaning that we have no more points to check. And then we just output our answer, which is the shortest path for the end spot. So this is the saved number at shortest path at the end point, and that's it. Flood fill, fun. Yeah, that's all I have for you guys today. Hope you guys enjoyed. I'll see you guys tomorrow for day 13. Peace out.